The moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese lunar orbiter was gathering data around the moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon. There's a special type of tree called a moon tree. It's grown from seeds that were taken into space during one of the missions and then returned back to Earth. You can find this kind of tree growing across the US. Earth is 27% bigger than the moon and far more massive. Our gravity is stronger. If you drop a rock on the Earth, it will fall faster. 150 pounds on Earth is just 25 pounds on the moon. The Earth has numerous satellites circling around it, but the moon is the only natural one. Our moon was formed during a big collision of the Earth and one more planet the size of Mars. This happened around 4.6 billion years ago, shortly after the Sun and our solar system were formed. After the collision, a cloud of vaporized rock went into orbit around our planet, cooled, and shaped into a ring of small solid bodies. They later got together and became the moon, leaving craters as a reminder of this collision. If you're standing on the surface of the moon, your shadow will be darker than on Earth. This is because there's no atmosphere to scatter light and create lighter shadows. One of Jupiter's moons, Io, has hundreds of volcanoes and pretty wild eruptions, sometimes sending plumes 250 miles into the atmosphere. These eruptions happen because of the extremely strong gravity this moon is exposed to. Its insides tense up and relax in those periods when it gets closer to and then further from Jupiter, which generates enough energy for insane volcanic activity. It's not just planets, even quite small space bodies sometimes have moons. In 1993, researchers discovered a 20-mile-wide asteroid and its 1-mile-wide moon. You'd need 400,000 moons to match the brightness of our central star, the Sun. The moon reflects the light it gets from the Sun, but it doesn't produce its own. That brightness depends on the angle between the moon, the Earth, and the Sun. Our moon is around 32 Earths away from us, and 29 Earths at its closest. When the night is dark and clear, it seems like you can touch a full moon. But if you wanted to do it, you'd have to travel up to 250,000 miles. Still, there is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think that water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets, which contained water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says that the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. Out of 200 moons in our solar system, our moon is the 5th biggest one. Jupiter's moon Ganymede is the biggest one, almost 1.5 times bigger than ours. Apollo 11 was the mission where humankind first landed on the moon. It was a very important moment, broadcast all over the world. But it was almost interrupted by a huge windstorm that was going on in Australia back then. Parker Dish was placed there, which was something we used to get the broadcast signals from the moon. The moon is not a perfect circle. It's more in the shape of an egg, with the thicker end pointing toward us. This shape is derived from its rotation. A full moon can keep you awake. Studies showed that people experienced less deep sleep, and it took them longer to fall asleep during the full moon period. It wasn't about its brightness, but the lunar cycle that influences our internal body clock. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. In 1 year, it moves around 1.5 inches away, which means that in around 600 million years, it will be 14,600 miles further from Earth than it is now. This number isn't accidental. That's the time when total solar eclipses will stop happening. Humankind hasn't set foot on the moon in a few decades, but footprints there are still fresh because there are no winds up there, so these tracks can stay there for millions of years. The moon has its own time zone called lunar standard time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got named after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. There are possible energy sources for living beings on one of Saturn's moons. It has an ocean under the surface, and it may feature some chemical reactions similar to those that help certain forms of life on our planet survive. The moon used to have active volcanoes, probably during the time of the dinosaurs. Molten lava hardened on its surface billions of years ago, which helped create unique lunar craters, but the volcanoes have been dormant for a long time now. The moon has earthquakes, or rather, moonquakes. Just like our planet, the moon also has a crust that goes through changes and shifts. Shaking occurs when its crust warms and expands, or it can even be caused by meteorite impacts. Moonquakes are not as strong as earthquakes, but can last way longer since the moon doesn't have enough water to prevent seismic vibrations. The moon has a big range of temperatures because it doesn't have an atmosphere. During the day, it can go up to 200 degrees Fahrenheit, but at its poles, the temperature is around -400 degrees Fahrenheit. In 2019, astronauts discovered a strange space phenomenon. The moon was crossing in front of the sun, and at one moment, it seemed like it stopped and then started moving backward. It's the same optical illusion like when you're driving on the highway and pass a car that's slower than you. At one moment, as you move ahead, it may appear like it's going backward. The crust of the moon is not equally thick in all its parts. Some are up to 37 miles thick, while others are much thinner. The moon itself doesn't change colors. When sunlight goes through our atmosphere, it reflects off the moon and makes us see it as pink or red. Sometimes there are particles of dust sent into the atmosphere, and in combination with sunlight, they give the moon an orange glow. The moon doesn't have a dark side. There's only a far side that we can't see from the Earth. The moon spins on its axis once and makes a circle around the Earth, all in the same amount of time, which is why we only see its one face the entire time. All planets in our solar system have at least one moon, except for Mercury and Venus. Mercury has less mass than our planet, so its gravity is lower than ours, around 38% of the Earth's gravity. That means 100 pounds on Earth would be 38 pounds on Mercury. Because of the weaker gravity, and since it's so close to the Sun, Mercury wouldn't be able to have its own moon. It would probably crash into Mercury, or even go into orbit around the Sun, and someday even get pulled into it. Venus most likely doesn't have its moon because it's also too close to the Sun.
Every April, a group of scientists observes the faint glow of asteroids passing by our planet. One year, they realized there was something weird shimmering in their telescopes. The team expected it to be another asteroid, but they ended up very surprised because what they discovered was an unusual space rock that didn't consist of the minerals that usually make up asteroids. It was made of silicate, the material mostly found on the moon. They named it Kamo'oliwa, which is a Hawaiian word that means wobbling celestial object. The rock didn't match any near-Earth asteroids scientists had already been familiar with. Instead, that piece had a pattern of reflected light, similar to that of the moon rocks astronauts had brought back from NASA missions. This fragment turned out to be a quasi-satellite, which is a kind of asteroids that orbit both our planet and the Sun. It repeatedly circles Earth and has a quite unusual tilt. That's the reason you can only see it in the night sky once a year. The fragment is pretty shy, too. Aww. It never gets closer to our planet than 9 million miles. That's almost 40 times as far away as the Moon. Plus, this space body often hides in the shadows. Scientists have figured out the piece won't stay in this orbit for a long time. It probably arrived at its current position about 500 years ago, and its orbit is likely to change in the next 300 years. This fragment may not be alone out there in space. There are at least 3 more similar near-Earth objects. They may have all come from the same place. Researchers aren't sure yet about the nature of the rock, but they can find out more about this unusual space object if they send a spacecraft to collect samples and bring them to Earth. That's something China's space agency is planning to do later this decade. Now, the Moon appeared in the middle of chaos. There are several theories about how that happened. The first one claims the Moon used to be just a wandering body, similar to an asteroid. It formed somewhere in our solar system. Once, it approached too close to Earth and got captured by our planet's gravity. The second theory says that our planet was spinning so quickly that some material broke off and started circling around it. One of the largest pieces was the Moon. The third theory says that the Moon was formed at a time when our planet was going through its own formation process. But today, the most widely accepted theory goes like this. Once, a long time ago, but not in a galaxy far, far away, Earth collided with a Mars-sized planet. The debris and clouds of dust from the collision gathered around our planet and started circling it. Eventually, something that we today know as the Moon formed there. Apollo missions brought more than 1/3 of a ton of soil and rock from the lunar surface. These rocks show that the Moon had mostly the same building materials as our planet. This might mean they have a common history. If the Moon had been formed somewhere else and had been eventually captured by the gravitational force of our planet, it would have a different composition. Also, if it had been created at the same time as our planet or had once broken off, there would be the same minerals on both the Moon and Earth. But the minerals on the Moon contain less water. Plus, our planet's natural satellite is rich in materials that form fast at high temperatures. Now, the Moon isn't the only space body in the solar system with a mysterious past. Hippocamp is Neptune's moon, discovered in 2013. It's the smallest moon of this ice giant, a mere 21 miles across. It's very close to Proteus, the biggest of Neptune's inner moons. And no, Hippocamp is not a place for big African mammals to spend the summer. Scientists think Hippocamp probably formed from debris after Proteus collided with a comet. If Hippocamp had entered Proteus's orbit from some other place in our solar system, the bigger moon would have either swallowed it or booted the tiny moon away. But not even Proteus itself is among the first generation of Neptune's moons. It was formed from the remains of the planet's earliest system of moons. Those first moons were destroyed when Neptune captured Triton, currently the largest of its moons. The main evidence proving the collision was likely to happen is the fact that Triton circles around Neptune backward, unlike other moons orbiting the planet. Neptune captured Triton from the Kuiper Belt. That's an area filled with icy objects and rocky debris stretching beyond Uranus. That means Hippocamp is a third-generation moon, kind of like a second cousin twice removed or something. Now, the Sun also had a turbulent past. Our star appeared about 4.6 billion years ago. It's hard to study its early stages of life since that happened 50 million years before our planet was even formed. But recently, a team of researchers has discovered crystals that are over 4.5 billion years old. Hidden deep within meteorites, they've revealed some things about the past of our Sun. Before the planets were formed, our solar system had consisted of a central star and a massive disk of dust and hot gas spiraling around it. As the dust and gases cooled down, they turned into minerals, including the crystals found in the meteorites that landed on our planet. Those ancient materials were irradiated, unlike some younger substances. Researchers think something might have happened to the Sun after those crystals were formed. Perhaps the activity of our star was less intense then. Or maybe, for some reason, these younger materials couldn't travel to the areas where irradiation was possible. Dwarf planets give us a chance to sneak a peek into the ancient years of the solar system. Around 4 billion years ago, Jupiter's, Saturn's, and Neptune's gravitational forces joined. They sent asteroids and comets hurtling across the solar system, making them collide with different planets. All the dwarf planets from the Kuiper Belt For example, Pluto, Eris, Haumea, Makemake have their own moons that likely formed after some powerful collisions. Icy debris in orbits similar to Haumea's, for example, can prove the theory of an ancient collision. The debris it created simply didn't have enough energy to float away from the dwarf planet's gravitational pull. Ceres, another dwarf planet, has ammonia-rich clays on its surface. Ammonia isn't stable at the temperatures prevailing on Ceres, but there's plenty of this substance in the outer solar system. It means that Ceres was probably formed in those outer parts and got kicked inward. After all, the gas giants were migrating a lot at those early stages of the solar system. Or the dwarf planet could have formed in an asteroid belt, and ammonia somehow, let's say after a powerful impact, appeared on the dwarf planet. Ceres might help scientists understand icy moons better. The ocean floor on Earth has a high concentration of carbonate minerals, and some parts of Ceres have them too. This means this dwarf planet is like some sort of fossilized ocean world. Many exoplanets, a term used for planets outside the solar system, have also gone through pretty intense collisions in their early stages. This double star system is more than 300 light-years away from us, and its stars are at least 1 billion years old. Even though it's not young, this system still shows some signs of swirling clouds of dusty debris that haven't cooled down yet, which isn't something you'd expect from a star system of this age. This debris is still warm. It means there might have been a strong collision of two planets or some other space bodies of similar size in that region and relatively recently. So hey, everybody just simmer down. Dust particles circle around a young star. They stick together and grow bigger with time. That's how planets form. The leftover dust often settles in some distant cold areas. An example in our solar system is the Kuiper Belt. It's located far away beyond Neptune. As solar systems evolve, those particles keep colliding until they're so small they end up being pulled into nearby stars or kicked out of the system. Uranus spins on its side if you compare it with the rest of the planets in our solar system. And the only way we can explain it is a powerful collision in the past. Something much bigger than a regular comet or some other space body of similar size likely hit Uranus and knocked the planet on the side. It was probably a planet twice the size of Earth. It could be a protoplanet. This is a space body made up mostly of ice and rock that orbits a star and is likely to develop into a planet sometime in the future. Anyway, the fallout from the impact smothered the core of Uranus. It prevented the heat inside the planet from escaping. This might explain why Uranus has extremely cold temperatures on its surface. Man, bring a jacket and a blanket. There are a lot of space objects all around the universe, from stars to planets to satellites, comets, and asteroids. But our closest celestial body is the Moon, which has been subject to much research, theories, and even myths. As our only natural and permanent satellite, the Moon is in the top 10 list of biggest satellites in our solar system. It's located in an outer spiral arm of the Milky Way galaxy. Other planets in our solar system, like Mars or Jupiter, have many other moons. Saturn is the planet that tops this list, with an astonishing 82 moons, of which 53 have names. Shall I go through that list of names? No? Okay, we'll move on. Our Moon, with its mean radius of 1,079 miles, isn't the biggest moon in the solar system, but is the largest compared to the size of the planet it orbits. The difference between a satellite, like the Moon, and a planet isn't their size, although that might be your first thought. The largest moons in our solar system are really huge. Some of them are even bigger than planets. Jupiter actually has a bunch of these types of satellites, like the icy Ganymede. It's the largest moon in our solar system, larger than Mercury and Pluto. It may even have an underground saltwater ocean that can surpass all the water on Earth's surface. Our moon's diameter is a bit larger than a quarter of that of the Earth. When it comes to mass, though, it's 80 times less than our Earth's. To paint you a better picture, if you think about our planet as being a big hollow balloon, you would need about 50 moons to fill it. But let's look at our moon's size from a bit of a different perspective. How does it compare to the United States? Well, the US measures 2,800 miles wide horizontally, which means the moon is smaller in diameter. It's difficult for us to see it any other way, but what if our satellite was twice as big? Well, first, we would see way more of those solar eclipses. In present conditions, they can happen 2 to 5 times a year, and 5 times is more of an exception. The last time there were 5 solar eclipses in a year was back in 1935. You'll have to wait until 2206 to see the next event like this. I might be around for that. If the sun and the moon look about the same size from down here on Earth, but I guess it won't be a surprise if I tell you the star we're orbiting around is enormous. So if the sun was hollow, how many moons do you think you'd need to fill it up? Wait, no need to Google. You would need 64.3 million Earth moons, or about 1.3 million Earths. Yep, it's that huge. And while we're on the subject of our sun, it has a diameter of 864,000 miles. Its mass? Well, it's no less than 330,000 times bigger than that of the Earth. What is a star, though? I'm not a scientist here, so I'll try to keep it simple. It's a ball of bright, flaming hot matter held together by gravity. The reason why they give off both heat and light is that, well, they are very hot. Experts call the smallest stars red dwarfs because of their size and color. They're also the most frequent types of stars in our galaxy, with some of them being so tiny and dim they are invisible to people on Earth. It's the case of our nearest neighbor star, Proxima Centauri. Our sun is considered a medium star since it has an average mass, brightness, and life expectancy. There are also giant stars out there. They are rarer but easier to see. That's why you can safely assume that roughly every star you see after the sun is set is much larger than the sun. But enough about it. Let's bring it back to the star of today's show, the Moon, our only natural satellite. But is it? That may or may not be the full truth, actually. Back in 1997, a group of scientists stumbled upon an asteroid about 3 miles wide, looking like it was caught in Earth's gravitational grip. It looked like a satellite of our planet. They called it Crunia. It takes this guy about 770 years to make a trip around the Earth. It also seems that it will remain in a suspended state around our planet for at least another 5,000 years. The Moon is also kind of steering away from us. With each year, it essentially holds up some of our planet's rotational energy and uses it to launch itself about 1.5 inches higher in its own orbit. If the data we have available today is correct, back when it was born, our Moon was about 14,000 miles away from us. The distance now is 239,000 miles on average. So, what will happen when it moves away completely? Well, no more songs like Moon River, Fly Me to the Moon, How High the Moon, that's for sure. Then there will simply be no tides in our planet's oceans, and our nights would become darker. The seasons would look a lot different, and so will the lengths of our days. Based on current calculations in the science world, this will take about 50 billion years or so. So there's no need to rush out stocking up on flashlights just yet, unless you just like to hoard stuff. There's also another catch here. Our sun gets about 10% brighter every billion years. I'll spare you the calculations, but to sum up, it's more likely that long before the Earth will be left without its moon, the sun will have already swallowed them both. Gee, I don't find that any more comforting. But hey, what makes a planet, well, a planet, and why isn't our moon considered one? I mean, it's bigger than some other objects in our solar system, which are technically planets. For starters, a planet is a celestial body that does 3 things. It orbits around a star, not something else. It is massive enough to become roundly shaped because of its own gravity. And lastly, it has the power to snatch up any dust or fragments in its orbit as it continues to move around the sun. So, we've established that the moon doesn't orbit the sun, but it doesn't really orbit the Earth either. Both of them orbit a certain point stationed between them called the barycenter. It's about 1,000 miles below the surface of Earth, sure, but still some 3,000 miles from the center of our planet. Since this barycenter lies beneath the surface of Earth, we do not consider the moon a planet. To be able to do so, the moon would have to be either about 1/3 larger or 1/3 further away, so that the barycenter would be independent of Earth's surface. The moon does have some other planet-like characteristics, though, which makes it very special in our solar system. Firstly, it has a crust, a mantle, and a core. It also has quite an active geology, with events like our own earthquakes. You guessed it right, they're called moonquakes up there. Hey, do they have moon pies up there too? Nah, come on. Let's continue our space exploration a bit more. Wait, what? You can't hear me? Of course you can't, because space is utterly silent. Since there's no atmosphere in space, sound has no medium or way to travel for you to hear it. You will want to steer clear of Venus if you do wish to continue your outer space travels. It's the hottest planet in our solar system. It has an average surface temperature of around 840 degrees Fahrenheit. Hot! You'd think that's because it's closest to the Sun, but it's not the case. You would also think that the closest planet, Mercury, would then be the hottest. Well, since this one has no atmosphere that would help regulate the temperature, it tends to have bigger fluctuations. Your calendar would also be very messed up on Venus, since one day on its surface is about as long as a year on Earth. That's because Venus is rotating slowly around its axis, taking 243 Earth days to complete its own day. If you were to pit stop on Mars, be on the lookout for those blue sunsets. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars. Any diamond fans out there? Pack your bags, because there's a planet out there made of diamonds, and it's twice the size of Earth. They believe it's mostly covered in graphite and diamond. A spacesuit costs about $12 million, but a visit there would cover the expenses altogether, don't you think? And if you're not a fan of space explorations and prefer the comfort of our planet, here's some good news for you. We have more trees right here on Earth than there are stars in our galaxy, the Milky Way. We know there are about 3 trillion trees here on planet Earth and between 100 and 400 billion stars in our galaxy.
The Moon has long been believed to have formed as a result of a humongous impact with the Earth. A Mars-sized celestial body could have driven itself into our planet and made part of its crust shatter. The resulting debris then packed together in a tight ball, which later became our Moon. But there's one question that's been bugging scientists. The Earth's crust is poor in metals, so how come the Moon has so much metal within it? The latest research basically throws the main theory out the window. So we again know nothing about our closest neighbors coming to existence. On the Moon, iron is preserved in pristine condition because there's no oxygen. It simply can't rust there. But a couple of years ago, scientists made an unexpected discovery. In the higher regions of our satellite, iron is oxidized and actually rusting. At first, this finding perplexed astronomers to no end. The presence of rust might mean people can breathe, at least in certain areas of the Moon. But then the explanation surfaced. Oxygen might have got to the lifeless rock from our own planet. In the absence of atmosphere, solar winds beat the Moon relentlessly, and nothing can stop them. These flares could swoop some oxygen from the upper layers of the Earth's atmosphere and carry it all the way to the Moon. The molecules then come to rest at the highest points of the Moon's surface. That would explain why metals don't get oxidized in the ravines, and especially under the surface of the satellite. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance, thanks to which we can now thrive. But there's a new advance which suggests another scenario. In space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water, it would be enough to fill our oceans 1,000 times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth, not only thanks to fossilized remains of living beings, but came from outer space as well. The climate changes we're witnessing are most probably part of a natural cycle. Researchers from the University of California's Santa Cruz have devised a pattern in our planet's climate variations, and they look like extremely long seasons. Sometimes, these states could last for millions of years, and they're all related to how the Earth is positioned relative to the Sun. The seasons were dubbed ice house, cool house, warm house, and hot house, according to the prevalent temperatures. For the past 3 million years, for example, our planet has been in the state of ice house, since the last ice age was not so long ago. But humanity's actions, adding to the greenhouse effect, have pushed the climate state to warm house much faster than it would have come without us. When it finally comes, the overall temperature on Earth will rise to tropical values, something that the planet hasn't seen in over 50 million years. What a time to be alive! Back to the moon now. You can see it at different places, in different sizes, and even in different colors every night. The size and location are pretty easy to explain. As the Earth rotates around its axis and revolves around the sun, we see the moon traveling around the night sky and getting either closer to or farther from our planet. What makes it bright yellow tonight and ominously dark red tomorrow is a more complex thing. The natural color of the moon, as seen from outside the Earth's atmosphere, is brownish gray. From the surface of our planet, though, it may vary a lot. When seen right above our heads, it usually looks bright and almost white, because its reflected light passes through a relatively thin layer of the atmosphere. Almost nothing blocks and refracts the shine, so it's very clear. The moon can appear yellow, orange, or even red when it's seen just above the horizon. The effect is similar to what happens at sunrise or sunset, when the sun appears to be red. The light goes a much longer way to reach your eyes from that location, and much of the blue part of its spectrum gets lost. This turns the color of the light into a much warmer variety. Our natural satellite can also appear blue, and the reason for that is the presence of fine particles in the air. They refract the light anyway, so the moon is actually never the way it looks outside the atmosphere. But when they're larger than usual, they turn its color bluish. Finally, there's an extremely rare occasion where the moon can look purple. Nobody actually knows for sure why this happens, but astronomers believe it must be a combination of the atmosphere, dust particles, and maybe something else. There's no clear explanation. Moonquakes aren't something from science fiction. They don't occur as often as on our planet, and when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. There are Mars quakes too. For a long time, the red planet had been considered tectonically inactive, but more recent observations have shown it still has weak quakes from time to time. You probably wouldn't even be able to feel them if you stood on Mars's surface, but it means some geological processes are still going on underneath the red and dusty landscape. There's no dark side to the moon. Our satellite is tidally locked with Earth, meaning it's always turned to us with one side, while the other always looks away. The sun is much farther from us than the moon, and we're both turning round and round, warming and lighting this side and that in turn. It means that once in every short while, the moon is lit by the sun from either side. It's just that we can't see it from where we are. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. It moves around 1.5 inches away each year, which means in 600 million years, it will be 14,600 miles further from Earth than it is now. The number isn't accidental. That's the time when total solar eclipses will stop happening. There is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets. Those contain water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. For those of you who think the Earth only has one moon, there are 2 more asteroids locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet. That's why it looks like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one follows a horseshoe orbit around our planet. Its specific path brings this asteroid closer to us every 95 years. The moon has its own time zone called lunar standard time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got names after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. The crust of the moon is not equally thick in all its parts. The average thickness is about 31 miles, but there are much thinner and much thicker areas. This is sometimes due to craters found all across its surface, and there are also big hollow tubes underneath. A lunar orbiter found one such tube several years ago, and it's pretty enormous. Although the tube's shape is irregular, it could swallow an entire football field. Scientists are still unsure what they could find in its depths. It could be a tunnel system, or some geological wonder in there. The most popular explanation of this thing is that it's a lava tube, the likes of which can be found on Earth too. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube.
It was January 7th in 1610 when Italian astronomer Galileo Galilei made an astonishing discovery using his homemade telescope. 4 moons orbiting the planet Jupiter. By the way, these days you can make your own version of his telescope using cardboard tubes, lenses, and some superglue. The main point of this DIY telescope is to place 2 lenses at the correct distance from each other. You'll need 2 lenses. One lens should be concave, the other one convex. So one lens is curved out and the other one is curved in. Galileo's initial telescope was able to magnify objects approximately 8 times. He continued to improve it until it reached about 20 times the magnifying power. But let's get back to the main story, shall we? When he first looked at those 4 moons of Jupiter, he believed he was simply looking at a bunch of stars. But he soon noticed that these space objects seemed to be moving in a regular pattern. It took him a couple of weeks to figure out that what he was looking at were not stars, but moons circling Jupiter. Galileo initially named those moons 1, 2, 3, and 4. But let's face it, those weren't the most creative names. As more moons in our galaxy were discovered later, the numerical system for naming them became confusing and impractical, so it lasted for just a few centuries. So, these days, those 4 satellites, Jupiter's largest, are named Io, Europa, Ganymede, and Callisto. They're collectively known as the Galilean moons to honor the man who first noticed them. Galileo's discovery was crucial for our later understanding of astronomy. It was initially believed that other objects revolved around the Earth since it was seen as the center of the universe. We now know that there are hundreds of moons in our solar system. However, large moons, like those discovered by Galileo Galilei, are not so commonly stumbled upon. A moon is considered large when it's the size of our planet or bigger. Ganymede, for instance, is bigger than Mercury. We basically call Ganymede a moon just because it orbits Jupiter. Otherwise, it has all the other characteristics of a planet. It's no surprise that Jupiter has the biggest moons in the area. It beats all the other planets in our solar system in both size and mass. So no wonder it pulled in a lot of other objects towards it. Jupiter is believed to have in total almost 80 moons, with only 53 of them being given official names until today. The first of those Jupiterian moons to be discovered by Galileo was Io. What sets it apart is the fact that it has a lot of volcanoes. Io is the only space object to have active volcanoes in our solar system, apart from Earth. It's also nicknamed the Moon of Fire and Ice because of its sulfur dioxide snowfields. Io's outer layer is splotchy, featuring multiple colors like orange, black, yellow, white, and red. That's probably the reason why NASA described it as a giant pizza covered with melted cheese and splotches of tomato and ripe olives. Because of that sulfur though, Io doesn't smell that appetizing, something similar to a rotten egg. There are more than 100 mountains on the surface of this moon. They are a lot larger than those we see on Earth, some being bigger than Mount Everest. On average, these mountains are 4 miles tall and 98 miles long. Because of those active volcanoes and the intense radiation on Io, there's little chance that life as we know it could exist here. But hey, who's to say it can't have life the way we don't know it? Next on the list of Galilean moons is Europa, the smallest of the four. It's comparable in size to the moon. Europa has an entirely icy surface, with just a bunch of craters scattered here and there. Because of that outer layer, Europa is very reflective, making it one of the brightest moons out there. As for its age, scientists believe its surface to be somewhere between 20 to 180 million years old. Europa is about 4.5 billion years old. What lies beneath that icy surface is impressive. It may even hold the secret to life outside Earth. Ice forms here in two ways. The first is through congelation, a rather self-explanatory process. Ice just grows as the surrounding environment gets colder and colder. The other method, though, is a lot more fascinating. A layer of supercooled water found under the ice shell reacts when agitated. It then generates these crystals that make it look like it's snowing in reverse, floating upwards to the ice sheet they sit under. You can recreate this environment yourself at home. Take a bottle of purified water and place it into the freezer. If you don't have purified water anywhere near, just boil some water a couple of times to get rid of as many impurities as possible. Since there won't be any particles inside, once in the freezer, it won't turn solid. But if you take the bottle out of the freezer and give it a shake, the impact will make the water rapidly crystallize, transforming it into a slush-like consistency. There may be water on Europa, but there's little evidence so far that life exists on this moon. However, it's one of the highest candidates in the solar system for potential habitability. Some sort of life forms could adapt to live there in its under-ice ocean. That environment is most likely similar to what we can find in our planet's hydrothermal vents hidden deep within our oceans. The amount of oxygen in Europa's atmosphere is very little, but in 2013, NASA gave away some cool evidence. This yet again supports the theory that there's potential for life on this moon. It seems that Europa might be venting water into space. If this is confirmed by future observations, it could also mean that Europa is geologically active. It could also come in handy if we'd manage to study water sources one day. The largest of those Galilean moons is Ganymede. It's also the biggest moon in our solar system altogether. It's a low-density space object similar to Mercury in size, but having only half of its mass. However, Ganymede is the only moon out there to feature its own magnetic field. It's quite small though, and we can barely notice it from Earth since it's overshadowed by Jupiter's much more powerful magnetic field. Another cool aspect of Ganymede is that its atmosphere contains oxygen. Don't get too excited, it's not nearly enough to support any life forms living there. Back in December 2021, a 50-second audio clip was released, which was previously recorded by NASA's probe on its Ganymede flyby. For the inexperienced, the sounds were more similar to those of an old dial-up internet connection, but because of its quirky tunes, Ganymede was soon nicknamed Jupiter's singing moon. Finishing up the list of Galilean moons is Callisto, or the most heavily cratered object in our solar system. What's interesting about this moon is that its landscape has barely changed since it formed, and scientists are still debating why this is happening. Most other space objects go through loads of changes throughout their lifetimes because of events such as collisions with other objects, changes in orientation or speed, or chemical reactions happening on their surface. Callisto is also about the size of the planet Mercury, but it has a lower density. Jupiter's magnetic field has a lesser impact here, since Callisto is the furthest from the giant planet. Its surface is estimated to be a staggering 4 billion years old. As opposed to Io, Callisto is not geologically active. But scientists believe there might be an ocean hiding underneath the moon's surface, which may potentially harbor life. The fact that it's less impacted by Jupiter's magnetic field means that it features low levels of radiation. Given this suitable environment, we may one day end up setting a human base for future explorations here.
The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our Moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the Moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the Moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the Moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the Moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the Moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the Moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the Moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the Moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the Moon's poles, however, the temperature is always at around minus 400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the Moon's existence influences us so. In the Middle Ages, Scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon, and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color depending on various phenomena. The moon seen near the horizon will most likely be yellow or red-tinted. The rarer blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days.
Our moon exploration project started out in 1969. Sure, there have been some problems along the way, but astronomers are certain we'll get back up there pretty soon and with better knowledge and technology. However, there's an 800-year-old trick that might become way more useful than fancy GPS tech and powerful rockets. It's called the Fibonacci sphere. Some scientists at a Hungarian university stumbled upon this idea while studying the moon. They believe it might be useful to better understand how the moon spins and how it's a bit squished while it goes around Earth. You might believe that our planet and its satellite are these perfect little spheres floating in space. Well, that's not true. They are in fact like slightly deflated soccer balls because of all the gravity, rotating movements, and tides. The GPS technology we use here on Earth is already adapted to these less than perfect ball proportions. Remember, our planet is a bit flattened at its poles. If we're going to make a map system for the moon, we need to do the same for its shape, called a solenoid, or what scientists call the moon's version of our Earth's shape. Since the moon is less compressed than our planet, scientists have been taking a shortcut until now. They've been looking at our satellite as a simple ball shape. However, with all these new projects coming up in the following decades and even some exciting trips we might end up having on the moon, we need to be more precise. Scientists now believe we should get the real data and start drawing an accurate picture of the moon. Here's where the Fibonacci sphere comes in handy. It's a clever solution that's been used by mathematicians to spread points out evenly on a ball. Scientists recently used it to map around 100,000 spots on the moon using data previously collected by NASA. And what they found was crucial for our understanding of the moon's shape. For instance, we now know that our satellite's poles are about 0.3 miles closer to the center compared to the moon's equator. Sure, it might seem like a tiny detail, but if we adjust our GPS software accordingly before we land on the moon again, it might save us from getting lost up there. This level of math hasn't been done since the 60s for the moon, but we already know it works wonders here at home, so it only makes scientists better prepared for future missions. This isn't the first time people have used Fibonacci's findings to come up with clever solutions. We've also seen it put to work in finance, agriculture, and in computer science. Let's see where it all came from. Legend has it that the Italian mathematician Fibonacci wasn't really that interested in mathematical sequences at first, but rather in rabbits? So, he came up with this interesting puzzle. What happens if you place a pair of rabbits in a certain space for a year? He also set some theoretical rules. For starters, all those bunnies come in boy-girl pairs, and they can start reproducing after just a month. Each month, each bunny pair adds one more pair of bunny offspring. The last rule was that all bunnies would be invincible for the year. Doing the math, he got this series of numbers. 1, 1, 2, 3, 5, 8, and so on. If you look at this series again, you'll notice that every number is the sum of the two before it. The first two, that's your starting bunny pair. Next, you'll see the number 2, which is the first pair and their first offspring pair. Word caught on about this interesting sequence, and math lovers began studying it more closely. They started seeing this pattern very often in nature, like in how leaves grow on a plant or how seeds arrange on sunflowers. There's even a little experiment you can do to check it out. Start by grabbing some paper and a pen. Try drawing the Fibonacci spiral. Start with a tiny circle, then go bigger and bigger using those Fibonacci numbers. The first circle should just be a tiny dot on the paper, or the equivalent of 0. Next circle, 1 unit. Another circle, still 1 unit. Keep it going and you'll see that the circles form this spiral pattern. Even as it continues to grow, it keeps its shape. You might have also stumbled upon the Fibonacci spiral as a symbol of hypnosis. In all fairness, there's little evidence you can confuse someone by making them stare into a spiral for a while. But its effects on our focus and our optic nerves can't be ignored. After you've stared at a spinning spiral, you might see how objects get smaller or bigger depending on the direction of the swirl. It's easy to understand why some experience this sensation as hypnotizing. This interesting series of numbers appears in our day-to-day lives, even if we don't notice it. It can also be used in more practical instances, like converting miles to kilometers. Let's look at the series 1, 2, 3, 5, 8, 13. Pick any two numbers side by side. Say 13 and 21. Do the calculations and you'll notice that 13 miles is about 21 kilometers. Same with 34 and 55. Music and math might not seem like they're connected. But if you had asked the great Mozart, he probably wouldn't have agreed. It seems he was very passionate about numbers from early on in his career. He loved finding cool number patterns in music, like some sort of hidden messages. His own sister even remembered him doodling math all the time, even on the sides of his music sheets. Some scholars believe he might have even played around with the Fibonacci numbers. If that's really the case, then he might have used the ration to balance out parts of his tunes. What about other types of art? Well, it's also said that Leonardo da Vinci used the golden ratio in his masterpieces, like the Vitruvian Man and the Mona Lisa. Also, when it comes to great pieces of architecture, the Parthenon might have used this pattern too. Anytime you see buildings with columns spaced just right, you can be certain that's where the builders drew inspiration from. The Great Pyramid of Giza is another great example. There's no official record to prove it, but the pyramid's shape is so close to the golden ratio that it's kind of obvious. You'll also see this pattern appearing naturally in our environment. Go out in our garden and check to see if you have any pine cones lying around. See those scales? They're set up in a pattern according to the Fibonacci sphere. Even the bones in our body seem to be growing based on the same proportions. We've got one torso, one head, and one heart. Then there's stuff that comes in pairs. Our arms, legs, eyes, and ears, for instance. For the number 3, think about the composition of our limbs and the 3 main sections in our hand. The wrist part, the middle palm part, and our fingers, which are also split into 3, by the way. Oh, speaking of fingers, their bone lengths have this ratio too. This design helps our fingers move smoothly, especially when grabbing objects. The Fibonacci sequence can be seen in the way ocean waves curve, and how rivers split and flow too. Weather patterns can also follow this rule. Some whirlpools and hurricanes form and spread out in the same way the Fibonacci spiral does. Zoom out, and you'll see that spirals aren't just found here on Earth. They're also everywhere in space, and it isn't random. Most galaxies, including our Milky Way, are spirals. Think of it like this. Generally, stars in a young galaxy don't all appear at once. Some are faster when developing, others take their time. This makes gravity pull in different ways, making the young galaxy spin like a disk. As it spins, different levels of gravity stretch it into getting these spiral arms. On the flip side, if all the stars in a young galaxy appear at the same time, gravity just smushes it all into an egg shape, or what the astronomers call elliptical.
You might think high-tech telescopes let us see every inch of the moon, but that's not true. At our satellite's south pole lie giant craters untouched by sunlight for eons, stuck in pitch black, colder than Pluto, and almost impossible to explore. However, maybe we have to if we want to explore space. Because the darkness hides some must-have resources that will make life and long-distance travel in space possible. Yes, we're talking about water locked up as tiny crystals in the lunar soil. Now, water in space is always good news. You've probably heard that scientists are also obsessed with finding it on Mars. If the red planet has any type of water below its surface, it raises the exciting possibility that life might have existed there. Even microbes would be the biggest discovery in human history. That's why rovers are poking around Martian craters and drilling into the soil like some very dedicated space gardeners. But as incredible as water on Mars would be, water on the moon might be even more valuable to us in the short term. The reasons are simple: the distance and the gravity of the moon. We can reach our satellite in 3 days. That's almost nothing. It takes at least 7 days to reach New York from London via a cruise ship. But more important than the length of the trip is the possibility of using the moon as a pit stop. Stop, refuel, and relaunch so we can resume exploration. The gravity on the moon is only 1/6 as strong as Earth's. That's not just useful for endlessly entertaining yourself by jumping around. This difference means that launching rockets from our satellite is much easier compared to launching them from Earth, which requires a tremendous amount of fuel just to break free from the atmosphere. For example, the Saturn V rocket, which took astronauts to the moon during the Apollo missions, was made up of more than 90% fuel just to get off the ground. On the moon, however, it's much easier to launch a rocket. That means that we could carry heavier loads with less fuel. It's like being able to take a bigger suitcase on your trip. If we can find and use ice on the moon to create rocket fuel, it would turn our satellite into a practical and affordable stop for exploring the solar system. Not to mention that by applying some basic chemistry, we could extract oxygen from water and use it for breathing or rocket engines. Also, astronauts would need water to drink and grow crops on the lunar base. So, what do we know about the latest discoveries? For a long time, scientists thought the moon was completely dry. But in 2009, NASA basically crashed a rocket into a crater. It caused an explosion of ice and vapor, like fireworks, and finally confirmed that the moon had some kind of water. But how much? Well, enough to matter. The data suggests there could be hundreds of millions of tons of water ice locked up in the moon's polar regions. Some estimates roughly say 1.3 trillion pounds. That's about the same weight as 460 million cars. Not exactly lakes, but still a lot. And there still could be more. This water could also contribute to uncovering cool scientific secrets. The ice is ancient, which makes it like a time capsule from the early days of the solar system. Studying those frozen molecules might tell us not only how water got to the moon, but also how it appeared on Earth. Anyway, what's all that water doing on the moon? How did it get there? Scientists assume that some of it probably hitched a ride on comets and asteroids billions of years ago. Many of those space rocks carried ice, and some of that water ended up in the polar regions. Another source could be the way solar wind interacts with the lunar surface. In any case, however this ice appeared on the moon, the real trick is where it ended up, inside its polar craters. And while we can find the ice not only in the craters at the South Pole, that's where the largest, most stable reserves are believed to be. Some of those craters are enormous. One of the most famous is called the Shackleton crater, and it's over 13 miles wide and more than 2 miles deep. That's almost twice as deep as the Grand Canyon. The moon barely tilts on its axis, only about 1 degree, so the sun never peeks over the rims of those deep polar pits. The temperatures dip to around -400 degrees Fahrenheit there. Any water or chemicals trapped in that frozen dirt just stay there, locked away like in a freezer. Something really cool is that at the South Pole, you have parts that are stuck in the perpetual darkness, but some nearby mountain ridges get almost non-stop sunlight. Scientists call them the peaks of eternal light. They are perfect for setting up solar panels while still being close enough to access the icy treasures hidden below. The poles of the moon are the only places in our solar system we know of where perpetual day and night exist side by side. But the eternal night isn't just fascinating, it's dangerous. The terrain out there is absolutely unforgiving. We can't even simulate something like that on Earth. We don't even know what it looks like from the inside. It's worse than exploring the northernmost part of Antarctica while wearing a blindfold. So now that we know this, is that potential water even obtainable? That question is probably worth several trillions of dollars. Yes, there's water over there, but getting to it won't be like scooping ice cream from a bowl. What we're really talking about are microscopic ice crystals mixed into lunar dust. To make use of it, machines would need to dig and heat up the soil, then capture the vapor before it escapes back into space. And then there's freezing. Even assuming a human or rover could safely reach the bottom of a crater, it'd be almost impossible to navigate. Batteries and equipment probably wouldn't last, and it's impossible to use solar panels or electronics down there. They'd freeze in minutes. However, NASA's Lunar Reconnaissance Orbiter uses all kinds of radars and sensors to sniff out what the crater looks like inside. And now there's an even sharper tool, Shadow Cam. A camera so sensitive it can capture details in light 100 times dimmer than what our eyes can see. Basically, the ultimate night vision device. With it, we can finally map those pits without even setting foot there. That's why engineers are thinking up all sorts of clever solutions. Some concepts involve nuclear-powered rovers with headlights strong enough to carve through the dark. Others want robots that rappel down crater walls or hop across the floor like pogo sticks. There are even ideas for drills that could melt frozen soil and trap water vapor like condensation on a cold soda can. The silver lining is that this water isn't going anywhere. Until we improve our technology, the supply will wait for us. That being said, space agencies are already making advancements. In fact, more than half a dozen new missions are lined up over the next few years. NASA's Artemis program is getting ready to send astronauts back around the moon and then down to the South Pole. China's Chang'e 7 is planning to check out those dark craters. And private companies like Firefly and Blue Origin are gearing up to deliver equipment and experiments. Now, here's a bonus, lesser-known fun fact. The moon smells. When Apollo astronauts brought lunar dust into their landers, it mixed with the oxygen inside and ended up smelling pretty strong. They said it was like burnt gunpowder or fireworks. Lunar dust has nothing to do with gunpowder, but its particles are highly reactive. After sitting in space for billions of years, they reacted instantly with oxygen in the cabin, creating that smoky odor. Future explorers are definitely going to notice that smell too, since lunar dust tends to stick to everything. Let's hope that, aside from everything else, scientists will work out air fresheners for the moon base.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the Moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the Moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the Moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the Moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
The moon might be hiding trillions of dollars worth of materials beneath that dusty surface, and NASA is about to get a piece of it soon. Their new lunar drilling tech just passed its first big test, and it could open up an entirely new frontier: space mining. This isn't just a scientific milestone. This could change the US economy forever, and maybe even reshape life on Earth. That's because they found something rare in lunar soil. Something that could become essential for us in the future: helium-3. Okay, so you know helium, right? It's the gas that makes birthday balloons float. Helium-3 is not that. It's a special isotope of helium, which basically means it has the same number of protons, 2 by the way, but a different number of neutrons. That's chemistry speak for it's rare, like super rare. Here comes the sad part. Earth had helium-3 once, a lot of it, actually. But during our planet's formation, a lot of it escaped into space. Turns out, it's super light, so it didn't stick around. But we can still find it here and there, mostly inside our planet. I mean, there's some of it literally trapped underground. Or even a lot, as some recent studies might suggest. But still, the problem is that extracting helium-3 is expensive, limited, and seriously difficult. So difficult, in fact, that getting it from the moon suddenly sounds like a piece of cake. To really understand why extracting helium-3 in space might be easier, we need to quickly compare Earth and the moon. So here's the sun, right? This huge ball of fire in the sky constantly shoots out tons of helium-3. When this helium-3 reaches Earth, our planet's magnetic field acts like a giant invisible shield, basically saying, "Nope, not here," and it deflects most of it away. But the moon doesn't have a friendly protective magnetic field like Earth does. So when helium-3 reaches the moon, it hits the surface directly and gets trapped in the lunar regolith. I'm talking about that loose layer of dust, soil, and rocky debris covering the moon. And there might be tons of it, literally. Some estimates put it somewhere between 1 and 3 million tons of helium-3. The best part is that almost all of it is probably sitting right in the top layer of lunar soil. So instead of heavy-duty drilling, it could be as easy as just scooping up some moon dust. That's why a lot of people think getting helium-3 from our natural satellite could actually be way easier, or maybe even cheaper, than digging deep underground here on Earth. Now, you're probably thinking, why go through all that trouble? I mean, if it doesn't work for birthday balloons, what's the big deal with helium-3? Well, for starters, it's already being used in advanced medical tech, like magnetic resonance imaging and X-ray. But here's the real game changer. Helium-3 could actually end our dependence on fossil fuels for good. This rare isotope could be used for advanced nuclear fusion reactors here on Earth. In other words, it could give us nuclear energy that's not just super efficient, but a whole lot safer too. See, most nuclear power plants today run on a process called fission. They use uranium-235, and when those atoms split, you get a ton of energy. But you also get something else: radioactive waste. And yeah, it's just as dangerous as it sounds. But helium-3 is different. It could power future reactors with a process called fusion. If you mix helium-3 with a type of hydrogen called deuterium, you get a lot of energy, but without the dangerous waste. It could be cost-efficient too. Let's say a single space shuttle cargo bay could carry about 25 tons of helium-3. That would be enough to power the entire United States for a year. And scientists believe there's enough helium-3 on the moon to power the whole world for 10,000 years. These are only estimates for now, but the future potential is so exciting that the demand for helium-3 is already skyrocketing, and so is its value. In 2024, some experts say that the helium-3 market was worth about $670 million. This year, it's expected to hit around 730 million, and 10 years from now, experts believe it could reach nearly $1.6 billion. Sorry for all the numbers, I just wanted to show you why mining the moon matters. It might actually save us from a future energy crisis by giving us almost endless, clean nuclear power. Everything sounds great so far, but there's one big challenge. Mining helium-3 on the moon is one thing. Bringing it back to Earth is a whole different story. So let's look at one possible solution. First, robots or specialized machines would drill into the lunar soil or simply scoop up moon dust to collect the helium-3. Then it gets packed into containers and launched off the moon, heading for Earth. When the containers get close to Earth, a ship called the Space Rapid Transit will pick them up in orbit. Think of it as a reusable space truck with engines that can even use air for thrust. Finally, the ship would land at an airport here on Earth. From there, the helium-3 would head straight to power plants, giving us clean, safe, and almost unlimited energy. See how challenging it sounds, right? Of course, specialists are still figuring out the best way to transport helium-3. But one thing is certain, we're getting closer and closer to building a full mining base on the moon. NASA recently tested a new drill technology called Trident. And as soon as it touched the lunar surface, it started working right away and performed perfectly. For now, its main purpose is to bring soil to the surface so scientists can study it. They want to learn more about how strong the lunar regolith is and how it reacts when drilled. That's definitely an exciting step towards extraterrestrial mining. Because it's not just helium-3, you know. There are a lot of other valuable things that can be taken from the moon. For example, there's water ice on the moon, and from that, we could extract oxygen and hydrogen. Then there could be rare and expensive metals like platinum, rhodium, and iridium. We could even mine iron, silicon, and aluminum, which would be perfect for building things directly in orbit, like future space stations or other infrastructure. Now that we know how important mining the moon could be, you're probably wondering, is any of this even allowed? I mean, who actually owns the moon? The short answer? Nobody. Even though NASA is up there doing research, that doesn't mean the United States owns the moon. Back in 1967, some nations signed the Outer Space Treaty. It basically says no one can claim ownership over our natural satellite or any other celestial body. Not an asteroid, not a planet, not even a random rock floating out there. So, if a country wants to explore the moon, sure, they can do it, but they can't plant a flag and say, "This is ours now." Here's where it gets messy. Companies. There isn't much of an agreement about what private businesses can and can't do out there. For example, a private company sets up a moon base. They land a successful spacecraft, build a small station, and even start digging. The base itself belongs to them, sure, but the land they're sitting on does not. Everyone is on the same page up to that point. The tricky part is, the treaty doesn't really spell out what happens to the materials they dig up. Nobody is totally sure if those resources would even belong to them. And if the materials are not technically the company's, can they even sell them? It's hard to say. So yeah, sorry. Even if you had the cash to build your own lunar base, you probably can't just scoop up helium-3 and bring it back as a souvenir. I mean, unless you want to risk becoming the first person ever banned from the moon.